In the second half of Unit E of Algebra 1, students connect different forms of quadratic equations to their graphs. The three forms of quadratic equations that students see are standard form, which looks like this, factored form, which looks like this, and vertex form, which looks like this. All of these equations represent the same quadratic graph, they are just written in different formats. In this video, we will be taking a look at Lesson 9, Task 9.2, which is about taking a factored form equation and converting it into its standard form equation. Take a moment to read the task and also the problems that students are asked to solve. There are 4 ways that students could solve these 4 problems, and I will go over all of the 4 ways. This first problem is asking us to show that x minus 1 times x minus 1 and x squared minus 2x plus 1 are equivalent equations by drawing a diagram or applying the distributive property. How I'm going to solve this is by using algebra tiles, which is what this diagram is actually referencing. So when we multiply using algebra tiles, it is helpful to have a template like this, and these are algebra tiles. So algebra tiles are just a way for us to visually see what's going on when we're working with various topics in algebra. So what we are doing is we want to multiply x minus 1 times x minus 1. So on the outside of this template here, I'm going to put an x, and these rectangles are x's. They are x long by 1 tall, and a minus 1. So these little squares are the ones pieces. Yellow means positive, so because that 1 is negative, I'm going to flip it over to the red side. And on this side, I am doing x minus 1 is also, so I'll have a rectangle for x, and a little square for 1, and again, I'm going to make that red for negative. Now what we're going to do to multiply these together is we want to find the area that these two sides make. So what I like to do is I do like to draw the box so I can see what size pieces I need. So I'm just going to draw the outside of my box first. And then what I'm going to do is I'm going to draw a line every single time one of my pieces ends. So this x piece here ends right here, so I'm going to draw a line going all the way down. I already drew the line for this piece ending here, and I'm going to do the same thing on the left here. So I'll have my x piece ending here, I will draw a line, and again, this is already finished. So now I can see what size shape I need, so I see that x times x is going to give me a large square. And so this large square right here is actually called x squared because x times x is x squared. This is positive times positive, so this piece needs to be positive. I can see this piece here needs to be a rectangle, so I know that this piece here is going to be x. So I have a positive piece times a negative piece, and a positive times negative is a negative, so I'm going to flip this over to the red side to say it is negative. I can see this piece down here also is going to be a rectangle x. So let me put that in. And again, I see that I have a positive green piece times a negative red piece. Positive times negative is going to be negative. And I have a little square here, so I know that this is going to be a ones piece. So I have a negative times a negative. Negative times negative is positive, so this is positive. So what I'm going to do is I'm just going to write this in for me. So that's x squared. This is negative x. This is negative x, and this is positive 1. So the nice thing about algebra tiles is that I can move these pieces around after I find the area. These pieces on the outside don't count for my area, so I'm going to move them off. And I can move these around so I can see what I actually have. So I can see that this area is an x squared, 2 negative x pieces, so negative 2x, and 1 positive 1's piece. And going back to my question prompt here, we're showing that x minus 1 times x minus 1 and x squared minus 2x plus 1 are equivalent. So I did my multiplication here. This is x minus 1 times x minus 1. And once I rearranged all my pieces here that were in my area, I have x squared minus 2x plus 1. So they are the same. The second method that students may use to multiply factored form together is the area model. The area model comes about by using the same idea that algebra tiles uses, is finding the area of the rectangle you make when you're multiplying two sides together. However, unlike algebra tiles, the area model does work a little bit better when you have larger numbers, just because you don't have to use a ton of pieces then. So how the area model sets up is you actually draw a rectangle or a square, and across the top and the left, we write what the sides of this rectangle is going to be. So one side is going to be x plus 1, and the left side is going to be x minus 1. It actually does not matter which you put across the top and which you put across the side, as long as they are on two different sides. And what I like to do is I do like to draw a line where we switch terms. So I have x plus 1, they are two different terms, we cannot combine them. So I'm going to draw a line here. And again, on the side here I have x minus 1, two different terms. I'm going to draw a line separating them. And we can see here that the algebra tile method and the area and bottom method look very similar at this point because you have four separate boxes. And what I'm going to do now is I'm going to color code this just so we can see the multiplication a little bit better. So when I'm doing the multiplication for area model, again, we are trying to find the area of each of these four rectangles. This top left rectangle is touching an x and an x, so I'm going to be multiplying this purple x times the pink x. And I know that x times x equals x squared. This top right box is going to be multiplying this positive blue 1 times this purple x. So I'll have 1 times x, and I know that 1 times x is just 1x. This bottom left box is going to be this dark pink x times this light pink negative 1. And I know that x times negative 1 is the same thing as negative 1x. Now this last box is going to be this blue 1 times the light pink negative 1. And I know that 1 times negative 1 is negative 1. At this point, to put this into standard form, we need to combine like terms. So I see I have an x squared, I have a 1x, positive because it doesn't have a sign, a negative 1x, and a negative 1. Now the only things I can put together are the x's right here in the middle, because this is x squared. X squared we can see here is a giant square. But x's are rectangles, and I have two rectangles here. I have a positive rectangle and a negative rectangle. So I know that 1 minus 1 is 0, so I can cross those off. So my final answer for this x plus 1, x minus 1 is x squared minus 1. A third way that students may solve this is by using the distributive property. So there actually are two ways to do distributive property here, and one of the ways is to distribute the x to the entire second parentheses and distribute the negative 2 to the entire parentheses. What this looks like is the x gets multiplied against the entire parentheses, so this becomes x times x plus 3, and then we'll multiply the negative 2 against the parentheses, so it'll be negative 2 times x plus 3. At this point, to finish solving this, we would have to do the distributive property again, so I would distribute the x times x plus 3, so that would be x times x, which we know is x squared, and then x times 3, which we know is 3x, positive because that is positive 3, and we would have to distribute this negative 2 to the x plus 3 as well, so that would be negative 2 times x, and negative 2 times 3. Now we do have to be careful here because this is negative 2 times x, so negative 2 times x is negative 2x. And we also have to keep in mind this is negative 2 times 3. So negative 2 times 3, negative times a positive, is negative. So negative 2 times 3 is negative 6. And at this point, we combine like terms. So I have x squared plus 3x minus 2x minus 6. The only things that I can combine are the 3x and the negative 2x because they both have x. This one's squared, it doesn't count, and this has no x. So when I combine those two things together, I'll have x squared. 3 minus 2 is 1, so I'll have 1x minus 6. And the fourth way that students might multiply factored form to standard form is something that I like to call double distributive property, which just means that we're doing the distributive property, both of these steps here at the same exact time. So part C says x minus 2 squared. When I turn this into standard form, we know that x minus 2 squared is the same thing as x minus 2 times x minus 2. This is very similar to the property that x squared is the same thing as x times x. So what I'm actually multiplying here is x minus 2 times x minus 2. And to do double derivative property, I know I have to multiply this first x against this first x. I also have to multiply the x times the negative 2. So basically, I am taking this first x and multiplying against both things in this second parenthesis. So I know that x times x is x squared. I also know that x times negative 2 is negative 2x. Now I have to do the same thing for the negative 2. Because keep in mind, I only did the derivative property for this first x. I need to do the same thing for this negative 2. So I'm going to do negative 2 times x, and then negative 2 times negative 2. So I know that negative 2 times x is negative 2x. And I know that negative 2 times negative 2 is 4. Negative times negative is positive. 2 times 2 is 4, so this is positive 4. And once again, I need to combine like terms. So x squared minus 2x plus 4. The only like terms I have are the negative 2x and the negative 2x, because they both have x's, and this one doesn't count because it is x squared. So when I combine these two together, I have x squared. Negative 2 minus 2 is negative 4, so I have negative 4x's there, and then plus 4.